All right. So today we're talking about importing and exporting, and we'll also do some web scraping here. Okay. So this is all about kind of getting your data in and out from R. All right. So I think you guys are familiar with your base R commands. Probably the one you use most frequently is read.csv. Okay. But then there's also readline if you want to prompt the user for input. You can use readline and basically whatever the user types in on the console, that will come in as input. So if you wanted to make a game where you ask the user what to do, you could use readline or something. Okay. Chutes and ladders. There's zero decision making. Okay. It barely classifies as a game because once you agree to play chutes and ladders, there's no you don't get to decide what to do. Okay, you just spin the spinner and then the action is done. Okay, so but if you wanted to play tic-tac-toe, there's some thinking, barely, right? But you have to say, I want to play in the corner or in the center or something like that, right? So that would be something where you'd use readline for that. Okay. If you got text data, use strings as factors. If you've got categorical data, you can leave strings as factors. Okay, the default setting is strings as factors is true. But if you've got something where people are writing comments and stuff, you don't want to treat that as a factor. Okay, the tidyverse. I'm a big fan of the tidyverse set of packages. That's basically RStudio and Hadley Wickham. They've created a whole set of packages that work with what we call tidy data, and we'll spend Friday going over tidy data and making your data tidy. And so there's a series of packages. Data tables, technically data.table is not part of the tidyverse, but Reader, ReadExcel, and Haven are. ReadR is one of the best packages for reading in things. Do you guys already use Library Reader, ReadR? Okay, so well, if you ever click the import button on RStudio, that I think it defaults to using ReadR's thing. Okay, so anyway, all of these you install using install.packages, and Reader is probably for your regular old CSV files, text files. Those are probably the most common way of distributing information. Okay, but if you've got Excel or if you've got data from other programs such as SAS, SPS, or Stata, you can use Haven and things like that. At UCLA, I don't know if anyone uses SAS, SPS, or Stata. Maybe the social sciences use SPSS a little bit. SPSS is a great program. It's a great program. I got nothing against it, but there's generally now a shift towards R only. Okay, and then our department used to use Stata, but again, a great program, but we're all going towards R. Okay, or not going. We've already done it. Okay, you can read it. There's some good webinars and stuff available, right? With package reader, you're going to use read_CSV rather than read.csv. That's like the only difference, and it's a lot faster. Okay, and then there's other kinds of text files that you can use, but read_CSV is probably going to be your most common one. And if you got a fairly big file, like a couple 100,000 lines or something, read_CSV is going to give you much better performance than read.csv. Okay, there's another package called data.table, and it's got a function called fread. Okay, F for fast. Okay, and it works very much like read_CSV, and it is designed to be really, really, really fast. Okay, so if you've got data files, say bigger than a gigabyte, all right, you probably want to switch over to fread. Okay. So I don't know if you do DataFest or something, and they give you a massive file. So depending on what year you do DataFest, sometimes they give you a large file of a, in the tens of megabytes, okay, with several thousand rows, and other times they'll give you some massive file with gigabytes of data with millions of rows, okay, and you can do interesting analyses in any case, okay. All right, this is straight from the website, the difference between read_CSV versus fread and data table. So read_CSV is a little bit slower, but uses a slightly more sophisticated parser. Basically the reader functions are designed to be a little bit more general, where fread is designed to be just as fast as possible. If you ever work with Excel files, which I think is still fairly common in the business world, okay? I don't know, in the stats department we kind of turn our noses at Excel, but I love Excel, okay? Excel is really great. You can do quite a bit with it. Same with Google Sheets, you can do quite a bit with it. And so anyway, you can import stuff using read Excel, read_Excel, and then as you know, or as you might know, Excel worksheets often will have several sheets, okay? CSV files, obviously, you can't have several sheets, it's just one file. And so if you need to specify, by default it will only import the first sheet, but you can specify sheets, which sheet to import by using the name or the number of the sheet as well, okay? There is package downloader, okay? Oops, I gotta kind of reformat that. Sometimes you need to download files off the internet, okay? And then so R has a base function, or not, it's in the utilities package, download.file, okay? And this used to work well in the earlier days of the internet, but now everything online uses HTTPS, the secure version of your hypertext transfer protocol. So pretty much all websites, when you browse, will have a little lock icon in the top left corner, and if it's not a secure thing, it's gonna say like not secure, right? So kind of the standard now is everything should be secure. And so the original download.file function struggles with secure connections. And so library downloader fixes a lot of those issues, okay? So, so sometimes on GitHub you'll find data files, and you can always kind of click raw, and it will give you access to the data file directly. And if you wanted to download that to import it into R, downloader can help. All right. If you want to export any of your files, okay, you can just use save, and with save you just list off all the names of the objects that you want to save, okay, and then you say file is equal to whatever .r data file, okay, and that allows you to give it to someone else who's going to use R, and they can load up the thing, okay, or you can just save, and I think by default it will save your entire workspace, everything that's currently in your global environment. It'll save that as well. Okay. If you want to save individual objects into a plain text file or something, so you can open it in Excel or open it in another program, something other than R, you'll probably use write. Okay. Write by itself is for atomic vectors, and it'll save it as plain text. Okay. So character vectors, numeric vectors, it'll just kind of save it as plain text. You can specify the number of columns, but generally you'll just say number of columns 1, and it just whatever your vector is, it'll go just straight down the line, okay? You can do this to matrices as well, and it'll just treat the matrix as an atomic vector. If you've got data frames though, you'll probably use something like write.csv, okay? Write.csv will create data frames, save a data frame to a CSV file. There's other options, okay? One disadvantage about a CSV is it doesn't save what encoding it is. And so, if you're using, UTF or something, it doesn't save that. And so if you go to another computer that's expecting ASCII, you can run into issues and stuff. But overall, write.csv is probably what you want. In general, I like to always specify row.names equals false, because by default, R numbers all of its rows. It gives all the row names, the numbers 1 through whatever, 1 through n, and that will get written to a CSV file, which often you don't actually want to keep that, okay? But sometimes you do. When you import stuff, okay, one of the issues you might run into is working with date information, okay? So if you think about it, okay, is a date a categorical or numeric variable? So today is January 22nd, 2020. When I write January 22nd, 2020, is that a categorical or numeric variable? Okay, so what's the criteria for something being categorical or numeric? What's that?
It doesn't make sense to compare like February 12th, January 1st numerically.
Does it make sense? Does it or does it not make sense to compare January 12th, February 12th, and January 22nd numerically?
You can convert it.
Huh?
You can convert it.
Okay, so I argue date information is numeric because it does make sense to say 3 weeks from now, 21 days from now, it will be this day, okay? It makes sense to say something like that. It's just that we're so used to seeing numbers in this base 10 format, right? 10 days from now, or everything's in base 10, right? Dates are just in this weird, Gregorian base format, okay? And so the way dates work is we've picked an arbitrary point in time, okay? 00 AD or, CE, whatever you want to call it. And I don't know, January 1, and we've called that January 1, all right? And then pretty much, so if there's like January 1, year 1, okay, 365 days later is January 1, year 2, okay? And then I guess 365 plus 31, so 396 days later would be February 1, year 2, okay? And so so dates are actually encoded numerically in the computer. I think there's some date, POSIX date, I want to say it's January 1, 1970 or something like that. And then all the dates are encoded as how many days have passed since this location in time. And that's why you can say, January 21 is 3 days before January 24th. And it makes sense to do those kinds of things. It's just somehow as a world we've accepted 365 days in a year, except for every 4th year, except not every 400th year, and then months, even months. Well, I don't know. These months have 31 days. These months have 30 days. February has 28, sometimes 29, and we've all kind of gotten on the same page, and we can write dates, right? But historically, also, if you go from one nation's history to another nation's history, there was no agreed upon year. And so they'll say like year 15th of the rule of King so-and-so and year 22 of the emperor whatever's rule, right? And we have to like look up the historical archives to kind of convert dates and stuff. But anyway, so dates are weird, okay? Dates are weird. And even though we've somehow got the whole world to agree on this kind of Western date format of months, 12 months, and this many days, it's still hard to work with, okay? So often dates will come in as strings, and you want to convert it into some kind of thing in date time, okay? So if you don't use lubridate, R has these as.date commands, but you have to format everything perfectly, okay? So if somebody writes out the full day, January 15th, 1999, okay, the full month has to be written with a capital B, okay, and then you say the day is %D, and then you put in the comma, and you say %Y, and then R will understand, okay, that is this, and it will say, year, month, day, something like that. But if you leave out the comma, R is like, I don't know what you're talking about, okay? I don't understand, okay? Same thing over here. If you've got dashes in between, you have to put the dashes in there. And if you leave out the dashes, R gets confused, okay? And so this can be very tedious, all right? It's not so bad if everything is formatted exactly the same way, but oftentimes you might ask somebody to enter their birth date into some web form, okay? And people will write different things, right? Some people will write with dashes, some people will write with slashes and things like that. And if you do it like this, the regular date format will only say, okay, this format works for this, but I don't know what the other ones are, right? This format with the dashes works for the middle one, but I have no idea what the other ones are. This one with the slashes works for the last one, but I have no idea what the other ones are, okay? And it can be very, very, very painful to have to deal with this, right? You have to do all sorts of cleanup and stuff. You often have to like parse everything out into like one column for the day, one column for the month, one column for the year and stuff, okay? Lubridate just makes everything easier, right? So you can just have like a vector of string dates, okay? And they're all written in month, day, year, okay? And you just say month, day, year, and it goes, boom, I understand everything here, okay? And this will save you a lot of headache, okay? The only thing that Lubridate does require is that you have to kind of write them in one particular order. If you say month, day, year, all the dates have to be written month, day, year. So, for example, if you see a date like this, 03, 04, 05, it's very ambiguous, right? If you're in America, you might say, okay, March 4th, 2005, okay? If you're European, that probably means April 3rd, 2005, okay? If you're military, it might be 2003, April 5th, or something like that, okay? And so that all depends on whether you've specified year, month, day, year, day, month, year, things like that, okay? And it will work. If you try to do something, like here is 25th, 12th, 99, I guess Christmas of 1999, but if you say this is in the format month, day, year, Lubridate will give you a warning and say, that doesn't work. There's no 25th month, okay? But anyway, strongly recommend Lubridate if you're ever dealing with date information. Okay, let's talk about Rvest. Rvest is what we're going to use for web scraping, okay? You install .packages Rvest, library Rvest, okay? It's kind of the package names, so Lubridate is kind of a play on lubricate, but like to kind of make things smoother. And here, Rvest is a kind of play on the idea of harvesting, or in this case, web scraping, okay? And you would use it in conjunction with something called selector gadget, all right? Rvest works really great for fairly static web pages where you have defined HTML tags. And I don't know if you've ever written a web page or created a web page, but HTML is kind of the way we produce web pages for your browser to show, okay? And it used to be, web pages used to be very simple, text-based things, and now we've made them way more complex and interactive, which is fine. It's just, that's how things improve, okay? Rvest, however, don't work super well with sites that are generated via JavaScript, okay? So a lot of sites these days feature infinite scroll because it's found to keep you on their website longer, right? So, because they found that every time you require the user to click their mouse, they're not just as likely, but it increases the risk of them clicking exit or clicking somewhere else, okay? But if you take away the requirement to click, people are happy to just keep scrolling, okay? And so, so pretty, Facebook, Instagram, Reddit, they all implement infinite scroll, so you just kind of stay on there forever. And the way those things work, it's not that they've created an infinitely long website, but they use JavaScript to kind of open a communication feed with the server, so that as soon as you reach the bottom of a web page, it says, give me more stuff from the server, and the server just gives your web browser more stuff to display, okay? RVest doesn't work so great with that, okay? It's expecting kind of a defined start and finish to your web page, all right? So that's that, okay? And it doesn't work well if you've got to be logged in, okay? So that's an issue. There's other stuff, okay? So here I just screen capped this from Reddit, and basically the way a web page works is you kind of write the text and you put the links for all the stuff you want to see, and then and the formatting is done using these tags, okay? And to kind of keep the formatting consistent, you'll name all of the tags of a certain all the elements of a certain type with the same tag, okay? And then somewhere on your on a separate page called the CSS, you say everything with this particular tag should be displayed this way, okay? And so here, on Reddit, each of these links, come with these subtexts that say like this many comments, share, save, hide, report. This many comments, share, save, hide, report. And to kind of keep those formatting consistent, all of those things have the same kind of comments, okay? So the underlying HTML, and I've cut a whole bunch of stuff to just kind of emphasize what you see, is, here it's a li as a list element, and they all come with these different classes, okay? And I'll say, this class is a comments class, okay? The share button is the share link is a share button class. Save button is save button class, so on and so forth. And every single one of these, if you look in the underlying HTML, will look that way. If I go to old.reddit, okay? So this is kind of what it looks like, and if you right click and you click view page source, it's a lot of stuff to read through, but in here, okay, it'll have stuff like the class and everything, and I've kind of simplified the text here, okay. And what we do is in the selector gadget, okay, it's going to look at all of these CSS tags, all right, and it selects all the tags that have select all the elements on the web page that have a specific tag, okay. So for example, here is the Reddit web page. If I click selector gadget, okay, it loads up this little thing down in the corner, and now that it shows puts little orange boxes around different elements on the website that I might want to highlight, right? So let's say I want to extract how many comments appear on each of these links, okay? So I'm going to just hover over this thing that says this many comments. I click that, okay, and it highlights a whole bunch of stuff in yellow, okay? I don't actually want everything that's highlighted in yellow, so I'll click something like here and say I don't want this, and I click that, and now it's only selected this one thing, okay? And I actually don't want this either. I just want the comments. So I'm looking, and it looks indeed like, okay, we've got this many comments, and stuff like that. And indeed, the tag that I'm going to use is going to be .comments. Okay, so I can just select this tag. Okay, copy that, and then when I come back to our studio and RVest, I'm going to say I want the .comments tag to select the all of these things that I want. Okay, and then we do this by using the rvest commands. One of them is going to say read the HTML. Okay, read the HTML from this website. Okay, and from there select all the nodes, all the HTML nodes where the tag is .comments. Okay, and then from there, so each tag actually contains several attributes. There's the text itself, and then within a tag. Within a tag, there's a whole bunch of things, right? There's like data spoiler equals false, data.oc equals false, data-num-crossposts equals 3, and stuff like that. And there's all these other attributes and stuff, and you can choose to extract those if you want. But here I'm just going to do the text, and so when I do this, it pulls out all the text. Okay, so from that website, it's just pulling all the elements that I wanted. In this case, 7 comments, 6,951 comments, so on and so forth. Okay, and then once I have this text, I can apply regular expressions to pull out the things that I want. We're going to cover regular expressions in I think next week. Okay, and it's a way for us to handle text data, string data, and pull out elements that we need. So one thing that you can say is just, I want anything that looks like a digit and pull that out. So we're going to do string extract from all of these things. I don't actually want the comment stuff, I just want the digits, and so we can see we get this stuff, and then we just do it as numeric. And now I've got numbers that I can use in R. Okay, I can make a histogram out of it, I can find the mean, I can find the median, things like that. Okay, so this is a way to kind of scrape, pull information from a web page. All right. Okay, this is just to kind of show that R struggles. So if the regular Reddit, if you just type in reddit.com, this will generate an infinite scroll website. Okay. And you can just keep going and going and going and going, okay? Whereas the old page, you know, it shows 25, and then you have to click next to go on to the next thing, okay? So this one just kind of keeps going and going and going. And so this is something where rvest is going to struggle, okay? It can still kind of do it, okay? You can still use the selector gadget, and I did it, but the tags are generated by JavaScript, and so this kind of tag is pretty much incomprehensible to the user. Okay, but this is I guess all of these things will be like the titles from the web page. Okay, and titles of the links. Okay, and this is likely to change like tomorrow, okay? Because this is all kind of JavaScript generated, and so this is not necessarily meant to be understood by a human, okay? Whereas if there is a static version of the page, so Reddit offers both kind of the infinite scroll version and the old-fashioned version. The old-fashioned version comes with a tag that says .title.may-blank, okay? So this makes a lot more sense, right? This is kind of your title text and stuff, and when you do this, it's gonna pull 25 things from the web page because there were 25 links on that front page. Okay. So both of these use the CSS selector, and the text is pretty much the same. It's just how the names of the tags change. Okay, and so this is just. I ran this like an hour ago, and so this was what the Reddit front page looked like at that time, and so that's that. Okay. If you want to work with one of these JavaScript infinitely generated sites, okay, there's other tools. Okay, one of them is called Selenium, and there's a way to work with it in R called R Selenium. It's a lot more complex to learn, but it can be done. And then if you're going to do some heavy-duty web scraping, I think most people would recommend Python. Okay, if you're going to build something that's going to crawl large amounts of the web. Okay, so Python has a few things. There's Beautiful Soup, which is kind of the simplest to learn, and that's good for like a couple of web pages. Scrapey will kind of build this crawler thing, and this is probably your versatile one, and then Selenium again exists also for Python. So those are some options. Okay, I wanted to do kind of a more in-depth Arvest demo. All right, and we'll just spend the rest of our class time doing an demo of Arvest. Okay. All right, so I'm going to start by, is this text large enough for you guys to read in the back, or do I need to blow it up? Make it a little bit bigger? All right. All right, we'll try 150. Is that better? Okay, all right, sure. Okay. So I start just by loading up here. Let me just kind of restart my session. Okay, I'm going to start by just loading the libraries Arvest and Stringer. Okay, and then and what we're going to do is we're going to go to this web page, and I'm just using in Arvest in the documentation. It uses pretty much the same example, and I've just modified a few pieces of it. Okay, so this is from IMDB, right? And you go there, and this is the IMDB page for the Lego Movie, and we're going to try to just extract different information, right? So one of the things that the IMDB has, probably that is their most used feature, is it lists off the cast in the movie, and you can click any of these people in the cast, right? So the voice of Batman in the Lego Movie is Will Arnett, and if you click his link, it will take you to Will Arnett's IMDb page, and this page will have all the movies that he starred in. Okay, so he's in the he's the voice of Batman in the Lego Batman movie, and they're making a sequel, Lego Batman Movie 2. Okay, BoJack Horseman and Riviera and Arrested Development, and all of these kind of these roles that Will Arnett is good at playing, right? I love the Lego Movie, and I love the Lego Batman movie. I think they're great. Okay, and then you can click any of these other things, right? Elizabeth Banks is the voice of Wild Style in the Lego Movie, and she's also in all of these other things like the Power Rangers movie and Charlie's Angels and stuff like that, right? So so there's all of these things, and it has all of this information about the different films that the actors are part of. Okay, and so the first thing that we're going to do is we are going to read in the HTML of that web page. Okay, so you just give it kind of the URL. So this is just whatever URL you have in the web browser. You say read HTML, and we're going to store it just as an object called Lego_movie. Okay, so it does that. It goes to the web page and it brings it in. Okay, and then so on the Lego Movie, let's say we want to extract this element, the movie rating, 7.8. So this is, I guess, IMDb users. 312,000 of them voted and said, this is my opinion of the Lego Movie on a 1 to 10 star rating, and this is what they get. And so what we'll do is we'll use the selector gadget, okay? And let me just move my thing here, okay? And we're gonna just hover over this number 7.8, which is the element that we want, okay? And as soon as I click that, okay, it selects everything with a span tag, okay? And so everything in yellow is going to be selected. There's 592 elements that it's going to select. We don't want 592 things. So I'm just going to start clicking things that I don't want, okay? I don't want it to pull out this element 2014, okay? And just by clicking that, it says, okay, we're going to use .rating value span, and it looks like it significantly reduced things just down to 3 things, okay, which is good. And if I look carefully, it looks like this number 10 is selected, and I don't want that, so I'm going to just click that, okay. And now there's only one element selected, and it's using the tags strong and span, strong span. So I'm going to just highlight this text, copy it, okay, and then let me exit out of the selector gadget. And then, and the way I write my code is I say select the nodes where the tag is strong span, okay? So I'm going to say take the HTML text in the Lego movie, feed it through this next function called HTML nodes, which will pull these things out, and then and extract the text, okay? Now if I stopped here, okay, then rating will be a character string, 7.8, okay? And what I want is I want it to be a number that I can do math with, and so I'm going to just use the pipe and push it into as numeric, and now rating is the number 7.8, okay, which is great. Okay, we can do other things, right? So there's if here we want to extract out the names of the cast, again I can use selector gadget. I'm going to come here, click Will Arnett, all right, because I want that. I don't want this other stuff, okay. And just by clicking one of these things, it says, okay, the tags that we're going to use is going to be TD:"nth child 2A. All right, it's a little bit weird, but sure, we'll go with it. And okay, I guess last time I did it, it gave me something slightly different, almost exactly the same. Okay, and so I'm going to just say run the nodes. Okay, and then we want to pull out the text. Okay, so when I do that, it now has all the people. It's got Will Arnett, Elizabeth Banks, Craig Berry. There's a little bit of, there's a space in front of each thing, and then there's a new line character after. So we can just use string trim, and that trims off the white space. So we're going to just run that, and now the cast looks like this. Okay, so we've got the names of our cast members. Okay. There's other stuff if you wanted to pull out, like, say, the first review. This is something that you can extract, okay? And when I do that, it pulls all the text. It says, I went into the Lego movie expecting drivel. I thought it'd be like the DC ones, but without the DC element to appease me. Thankfully, I was wrong, okay? And this user gave it 7 out of 10 stars, okay? All right. Okay, other things. So again, if you're familiar with HTML, you can pull out HTML attributes. Yes, is there a question?
Sorry. For the review, is there a way to extract it while keeping that layout that was, or that format that was on the website?
So, let's see. It just pulls the text. So yeah, you do lose a little bit of stuff. Okay, it's just however the stuff is stored on the HTML thing, and so it must be removing new line characters. I'm not quite sure what's happening there. Okay. Okay, and again, if you're familiar with HTML, you know that there are different attributes. Okay, so certain tags will come with attributes, and maybe you're interested in pulling the attributes. So for example, images are stored in an attribute called src. The URL of an image is stored there. And so here we can select one of the tags and pull out the poster. And then if I follow this link, right, or if I use like download.file, I can download the poster and download the poster of the movie and things like that. Okay, and okay. Oh, I got just a couple minutes left. All right, one of the most impressive features of Arvest is you can create an automated browser session. Okay, and so you use the tag HTML session and you give it a starting web page. Okay, and what we want it to do is this is what I want it to do. I want to start on this web page. I want to come down here. I want it to click on Will Arnett, go to Will Arnett's page, okay? Look at his filmography and pull out the movies that Will Arnett's been in. Okay, so we're going to go down to here, go down his filmography, pull out his movies. Okay, then we're going to go to Elizabeth Banks, go to her filmography, and extract all of her projects. Okay, and we're going to just kind of go down the line. Craig Berry, Alison Brie, and we'll see all the stuff that these people are in, and we want to kind of pull out all of these things, okay? So the way we're gonna do this, okay, is that there's a function called follow link, okay? Follow link, you can give it either a number, and it will be like follow the 10th link on the page, and just starting at the very top, and it's really hard to do, okay? Or you could say follow the link where the text is Will Arnett, okay? And hopefully, there's only one link on the page with the text Will Arnett, okay? By default, it's gonna just follow the first link with the text Will Arnett, okay? So if I do this, I could say start with our session, which when I created my session, I stored it as S. And I say start with my session, follow the link to Will Arnett's page, and pull out the HTML there, right? Okay, and now I've stored Will's page here. And from Will's page, I can pull out, I looked up what nodes I need, and if I pull out the nodes B space A, that will pull out all of his movies, okay? And so when I do that, indeed, it pulls out the projects of his filmography. Rumble, First Team, Batman movie, Lego Batman Movie 2, so on and so forth, okay? There's other things I want to pull out. Maybe I want to pull out the year that he's working on, okay? And that can be done with these nodes. And we can say, all right, these are, the year 2020, there's no year for the second thing, 2022, and so on, and for Will Arnett, indeed, we got 2020, there's no year for this thing, 2022, so on and so forth, okay? But I want to do it for all of my actors, okay? So what I'm going to do is I'm going to create an empty list here, okay? I'm going to start by creating an empty list. And then, again, I have the names of the actors stored in cast. All right, hang on, you guys. Okay, I still got a minute here. Okay, and we're gonna just say follow the links: Will Arnett, Elizabeth Banks, Craig Berry. Okay, and Alison Brie. We're just gonna do it for the first 4. Okay, and so I kind of used the exact same form here, except for Will page, I just changed it to actor page. And when we just say follow the link for the actor name, read in the HTML. From each actor's page, pull out the movies. From each actor's page, pull out the years. And then repeat the actor's name so we can store it in a table. And then what I do is I create a data frame using all of those vectors that I've created, okay? So I'm gonna go ahead and do this, and this will, and you can see the browser navigating to these different web pages, extracting that information, okay? And now when I do this, I can take a look at cast movies, all right? And I've got a list of 4 different data frames. I've got the first element in the list is Will Arnett's data frame. The second element of the list is Elizabeth Banks' data frame, and so on and so forth. And then so I can just R-bind each of these data frames together, okay? So I can just start by saying, okay, let's make a data frame called DF. And then for each element in the list, starting at the second, ending at the 4th, just R-bind those new elements, right? Okay, and I do that. And indeed now, I have a data frame with 40 rows, and it's basically the 10 most current projects of each of these actors, okay? And we got this, again, by having R browse to each of the actors' web pages, pulling out that information, and then feeding it back into a single data frame, okay? I think this is pretty cool, and this is pretty nifty that you can do, and it's very powerful, and with a little bit of practice, you can do some stuff. So we'll end there, and we'll see you guys on Friday. Go ahead and sign your integrity agreements, bring them back on Friday, okay?